The learning goal for these notes is to understand that if a function divides cleanly into another function, then the divisor function is a factor of the original function. What does that mean in layman's terms? That means that if I have something like 15 and I divide it by another number, if I get a whole number with no remainder, that whatever the divisor was is considered a factor, meaning it goes cleanly into the original number. So for example, you could put 5 here and you would get 3, no remainder. 5 is a factor of 15. But if I put 4 in, I would get a remainder. So 4 is not a factor of 15. So if there is no remainder, then the function is a factor. What does that look like? Well, in this case, we're going to look at how we could use this idea. So let's take this big idea approach here. Polynomial in any form, a linear, a quadratic, a cubic. So if it factors into pieces, right, if it breaks up into pieces, that's referred to as factored form, like this. Or if we multiply it all the way out, it can be written in what is referred to as standard form. So all functions where we have this a, x cubed, b x squared, c x to the first, d, or if this were a x to the nth, b x to the next one down from that, c the next one down from that, d maybe the next one down from that. There could be a whole bunch of these terms, or even an infinite number if it were meaningful. But when you multiply all of them out, you're going to get standard form. Okay. So this one is standard. And if I write something as a product of its factors, that's referred to as factored form. So we're going to use this big idea here with this no remainder idea. So if ax cubed plus bx squared plus cx plus d were divided by a times the quantity, x minus r, and there is no remainder, then the quotient is the product of the remaining factors. So that might seem a little convoluted at first. So let's go back and think about it. So we're going to think about this initially as some really just plain simple numbers. So think about this. If I have 24, and I could write that as 2 times 3 times 4, right? So if I think about it from a division perspective, 24 divided by 4 is 6. And what is 6? It is the product of the remaining factors. What are the two remaining factors? 2 and 3. So 6 is the product of the two remaining factors, 2 and 3. Okay? So if I were to take this whole thing and divide it by this, the answer would be these two components right here. Whatever was left would be this thing, this quadratic, multiplied out in standard form. So let's look at an example. So let's say I'm looking at this cubic here, and I want to know if x minus 1 is a factor or not. Does it go in cleanly? In other words, if I were to graph this cubic, would it cross the x-axis at x equals positive 1 and get a 0 out? So is it a factor? So I can check. Divide it in. All right, x minus 1, 2x squared, and then multiply to each piece. 2x cubed minus 2x squared. And then I'm going to subtract and get minus minus makes plus 3x squared. Drop our term. X goes into 3x squared. 3x times, so I'm going to say 3x times x makes 3x squared, and then 3x times 1, that's negative, gives me negative 3x, and I'm going to subtract and get 0. And this is going to give me positive 1x, because negative 2 minus negative 3, that becomes a plus, making 1. Drop this negative 1 right here. Now how many times does x go into 1x? It goes in 1 time, and I'm going to multiply through. It's going to give me x minus 1. And that gives me 0. So what does that mean? There is no remainder, which allows us to infer that this right here is the product of the two remaining factors if it cleanly factors. It also means that if I were going to graph this cubic, then the point 1, 0 would be a point on it, because factors are when it goes across the x-axis. If it's a real factor, imaginary ones are a little different. And it also means that it divides in cleanly. So I could say that x minus 1 times 2x squared plus 3x plus 1, that this right here is the same thing as this. It's sort of like saying that 24 equals 4 times 6. I haven't broken down the 6 yet. Maybe 6 breaks down, maybe it doesn't. Let's pretend I don't really know my numbers. But we could maybe figure it out if we worked a little. So this is our 24, this is our 4, and this is our 6. The answer to the division question, the quotient, times the divisor equals the original question. Now, let's say I want to go a little further. I want to go from 224 equals 4, and I'm going to break it down into 2 times 3. I want to break this guy up even more. So how do I do that here? Well, I'm going to take this quadratic, and I'm just going to come over here and say, well, heck, I know how to factor a quadratic, and that's really straightforward. So I'm going to take 2 times 1, which gives me 2. And then what two numbers multiply together to make 2, but add to make 3? Well, that's just 2 and 1. So 2x squared, 2x, 1x, 3. And that's going to give me 2x by x by 1 by 3. So if I wanted to break this up down further, like we did here, we took 6 and we broke it down further. We're going to take this and break it down the rest of the way and say that it could also be the same as x minus 1. That's just this part being rewritten. And now we're writing this quadratic as the product of two linear factors also, those being 2x plus 3 and x plus 1. And I'm going to leave that for a second, and then I'm going to close this window briefly and refresh it, because sometimes that helps the focus of these cameras. Sorry guys, let's open it again. Okay, so how do I use this? Generally in standardized test practice, that kind of thing, what you're looking for is, we're trying to determine, it'll give us something like, here's a linear function, tell me if it's a factor of this. So what they're asking is, they're asking you to say, does this divide into this cleanly, as in with no remainder? Because no remainder means factor. Okay, so think about it this way. Is 5 a factor of 21? No. How do we know? Because there's a remainder. Is 5 a factor of 25? Yes, because no remainder. So that's kind of what we're thinking about here. If someone were to ask, is a linear function a factor of a polynomial? It would be yes or no, and the answer is always the same, because there was a remainder or because there was no remainder. So we're going to come down here and we're going to say x minus 3 divided into the polynomial I was given. If there is no remainder, then x minus 3 is a factor, and x equals 3 produces f of 3 would output a 0. So we can break it up a little further. More long division. So x squared, distribute through, minus 3x. We're going to subtract. That's going to be 0, and that's going to be 6x squared. So that's going to be 6x. X goes into 6x squared, 6x times, multiply through, 6x times x is 6x squared. Don't forget to drop your term. So 6x squared, 6x times negative 3 is negative 18x minus, that gives us 17x. Bring down our number, negative 3. So x goes into 17x, 17 times. 17 times 3 is 51. We would subtract, and we would get remainder of 48. So if this were a factor, we would have gotten 0 at the end. Okay, so no. If we needed to, you might be able to break this up and say that x cubed plus 3x squared minus x minus 3 is equal to x minus 3 times x plus 6x plus 17 plus, and then you would write your little fractional amount, 48 over x minus 3, just like if we said 21 is 5, let's see, 21 divided by 5 is the same as 4, because it goes in cleanly with a remainder of 1. 1 what? 1/5. So that's similar to what we have written there. Sorry about the not really sharp picture there, guys. So one last thing here for this particular section, which is given a polynomial and given a root of the polynomial, we can factor this out the rest of the way. I can figure out what the roots are if I know one of the roots. So if x equals 3 is a root, then that means that 3, 0 is a point, and x minus 3 is a factor. So if it's a factor, it should divide in cleanly. So see if you guys can do this one on your own, and then check it off with Miss Henderson. So if you were working on this in class, or if you choose to preview these notes at home, I want you to work through this one on your own and then put a little box in the corner where I can come around and initial that it's done. We'll be looking at a few more notes on if I had a bunch of roots, could I write a factor, which is kind of going the opposite way, and we will look at that in the next video.